Okay, this video is going to be covering reflections. Again, most of what we're doing with reflections is simply going to be a review from 8th grade, which I know some of you it's been a couple of years. But let's go back over. As you can see, I already have some things set up here to save time on the video. So if you want to pause and set this up or set it up as we go, what we're going to be doing is looking at reflection on the x-axis and the y-axis first. So first, looking at your x-axis, remembering where your x-axis is, right here. So we're going to reflect point A, which I already have plotted. Go ahead and make sure you plot point A as well as please label A. When we go across the x-axis, you have two options with this. You can count how many units to get to the x-axis and then count that many on the opposite side. So however far you are on one side, you need to go to the opposite side the exact same. So if we move 1, 2, 3, 4, 5, we've got to move 1, 2, 3, 4, 5. Or we can follow the rule. Your rule for the x-axis is you're going to take the xy and simply change the sign of the y coordinate. So whatever axis you're flipping over, do not change that coordinates. Okay, as you can see, x-axis, do not change the x. You're going to change the opposite. So here, if we change those opposites, we're going to see, again, at -2, 5, keep your x coordinate the same. Change the y coordinate to the opposite. So it ended up being 2, -5. And then we could plot 2, -5, okay? And then I'm not going to work, because I'm using different colors, you know, I encourage you to use, I'm going to tell you right now, the most I'm going to be using on here other than the black as your pencil is 2 other colors. So if you'd like to pause and grab a couple colors, not a bad idea. Looking at the y-axis now, again, y-axis, we should know where that is located. That is going to be the vertical axis right here. Again, you can count how many to get to the y. Think of your line of reflection as the mirror. However far you are on one side of the mirror, your reflection is the exact same amount on the other side if it was a real person. So here you can move 1, 2 to the y-axis, move 2 past it. Or applying the rule, which is kind of where we want to go, it's practicing our rules. Your y-axis, just like the x-axis, you don't change the x-coordinate. On the y-axis, don't change the y-coordinate. So again, whatever axis you're reflecting over, do not change that coordinate. So here we're going to change the opposite coordinate. The x was at a -2. Okay, we've got to change it to the opposite, a +2. And then we leave the y coordinate, oops, sorry, my bad. We leave the y coordinate exactly the same as 5. So here we can plot 2, 5. This would be a reflection over the y-axis. We don't have to label it, but I did on that one. Okay, so that's your basic, simple x-axis, y-axis, one of the easiest ones to do. Now let's take a look at reflection over y equals x and y equals -x. Again, this is still review from 8th grade. First thing we need to remember is what y equals x looks like. That is a linear equation. Okay, so we need to remember that this is your y equals mx plus b. We don't have a plus b because it's going to cross through the origin. So your y equals x is simply going to be start at the origin, and it's going to be a rise over run of 1 over 1, 1 over 1. So all we're going to have here is we start here and we go 1 by 1. And this is going to be your line of reflection for y equals x, positive slope, okay? So when we take a look at the coordinates, same thing, -2, 5, which I didn't have plotted yet, so we can plot that together. You can do a count to the line of reflection, but I'm going to highly, strongly encourage that you do not, because you're going to have to count diagonally, and you could wind up, you're going to have a half, like if you look here, you'd go 1, 2, 3 and a half, and you'd have to remember to go half, 1, 2, 3. And the other thing is later in the next chapter when we get to distance, you cannot count diagonally. You're not allowed to. So I'm going to highly encourage that you follow the rule, okay? The rule for y equals x, you're going to take your x and a y, as all you're doing is you're switching them. Okay, you're going to switch those two numbers around. So here we're going to wind up with 5, -2. That's all we're doing. Switch the two numbers. It's not a hard rule there. Okay, so we go over here, we go 5 on the x, -2 on the y, and there's going to be reflect across y equals x. Y equals -x. Now we are going in a negative slope, -1 over 1. So it's going to be the complete opposite here. I'm going to turn my page, make it easier for me to trace. And we're going to go in the negative slope direction down the hill. So here is your y equals -x. And again, please just follow the rule. You're going to switch the two numbers. okay, just like we did, but now you're going to change the sign of both. Please remember that negative does not mean make it negative, because if it's already negative, we know a negative and a negative makes a positive. So all those negatives mean the rule is change the sign. So we're going to switch these two around. So we're going to have the 5, -2, but we have to change the sign too. So that 5 that's going to move to the x place is now going to be a -5. Okay, everybody understand that? Switch the sign and switch places. The -2 is now going to become a +2 and move to the y's location, y coordinate. So we're going to be at -5, positive, sorry, I'm going, yeah, -5, +2. So we got -5, +2 right here. And we can see, again, I encourage don't do the counting. It'd be 1.5 and then 1.5, but we can see that we do have that location across that line of reflection, same distance on both sides. Now, one thing that you may not have learned in 8th grade, depending on what your teacher taught you, because this technically does kind of jump up to the high school level of geometry, is reflecting when x equals a number and y equals a number. The first thing, going back to looking at our algebra, the first thing we want to pay attention to on here, let's go ahead and follow these steps. Draw point A on the graph. A is still going to be at that -2, +5, okay? Now we want to draw the line of reflection. The first thing we're going to go with is we are going to go with x equals -1. With your x equals -1, this is still a linear equation. You're going to find -1 on the x-axis, okay? So -1 right here, and that's the only place on the x-axis you want to touch. So which means it's going to cut through -1, giving you a vertical, completely vertical line of reflection. So this is going to be your line of reflection. As for rules, the best option here, because we're going to have vertical and horizontal lines of reflections, count to the line of reflection, count that many to the other side, like what we did, like what I showed you guys we can do up here on the x and y, okay, because it is going to be vertical and horizontal. So we see that we're going to move 1 to the line of reflection, so we want to move 1 more to the other side. And so this is going to give us our coordinates at 0 on the x. Always start at the origin to find your coordinates. Don't start on the line of reflection. We're at 0 on the x, and we're at +5 on the y. Okay? Then we're going to take a look at your y equals 1. So again, y equals 1. Find +1 on the y-axis right here and cut through it. Okay? It's the only place on the y-axis that we want to cross, that we want to touch. So here is your y equals 1. Again, we can take the A coordinate and we can go ahead and count 1, 2, 3, 4 to the line of reflection. We went 4, now we need to go 4 on the other side. 1, 2, 3, 4. And then here's our coordinates starting at the origin. Okay, we're going to be at -2 on the x, and we're going to be at -3 on the y. Now the last thing we're going to see here, reflect A in the line of reflection to create A prime, which we're going to get more. A prime is always going to be that, we didn't label it here, is always going to be the image after we're done. And I guess we can just name them both A prime for right now. And A prime should be perpendicular and equidistant from the line of reflection. Okay, so what we're talking about here, perpendicular, this is an extremely important word. Guys, please remember this word. Every year, this is the word that my students forget the most. Perpendicular, what needs to come to mind is 90 degrees. Please remember that. That will come up all year long, okay? It's going to form 90 degrees. And equidistant, we're going to be talking about several times as well, is simply just going to be equal distance. So what this last thing says is regardless of whether we're reflecting over x equals -1 or y equals 1, what's going to end up happening is if you draw a line from A to A prime, it's going to be perpendicular with your line of reflection, meaning it's going to form 90-degree angle. You can have 90-degree angles everywhere, as well as it's going to be equidistant, what I told you. Count to the line of reflection, count the same amount on the other side. So it's going to be exactly the same distance from the line of reflection. Okay? Next. Let's go ahead and take a further look. We're going to be talking about perpendicular bisectors just a little bit here, okay? Transformation that maps A to A prime across a line of reflection, K, such that if A is on line K, okay, so we've got A on line K, then A and A prime will be the exact same thing. We're going to see what this looks like. If it doesn't make sense right now, I'm just letting you know ahead of time. If your point is on the line of reflection and you reflect it, no matter how you reflect it, those 3 different ways you looked at, it's going to stay on the line. It's not going to move, okay? So let's take a look at exactly what this looks like. The first thing we're going to do here is we are going to take these vertices of this triangle and we're going to reflect over the x-axis. I highly encourage, get a highlighter. You need to highlight these lines of reflections, or at least draw in where they are at so it kind of sticks out at you. Here we're going to go over the x-axis, which is going to be right here. What I want you to do is I want you to pause and I want you to plot these 3 points and I want you to label them. Connect them into a triangle. I'm going to go ahead and pause the video. You're about to see my triangle pop up real quick, so go ahead and pause it and plot those points and connect them and label them. What you're going to notice here is the line of reflection is going to go through the pre-image, and that's okay. All this means is not all your points are going to go in the same direction. You need to move towards that line of reflection. So if you're moving it by counting the units, you need to realize that Y and Z are going to move downward. X is going to move upward, okay? The point is, whenever you get done, you need to make sure that everything is, that your pre-image and your image are the same shape and same size. Let's take a look at looking at the rule though, okay? So we're going to go from X, Y to, we're going over the x-axis. Don't touch the x coordinate. It's going to stay the same. You're going to change the sign of the opposite coordinates, okay? So here, we've got x at -5, 2. So all we're going to do is leave x the exact same at -5, but now we're going to change the sign of y to a -2. And we can go over here and we can plot -5, okay, there we go. -5, got a little mixed. It's going to be a +2. Sorry, that's a -5, -2. Boop, boop. There we go. See, everybody makes mistakes, guys. I was reading the wrong number. So a -5, +2. And guys, I'm glad I did that because I want you to see where I was going with that. I went -5, -2. I was like, oh, wait, x is already there. Something happened. So now you guys can see exactly how you can kind of check, did I do it correctly? Okay, so here at -5, +2, I found my mistake, whoops-a-daisy, and we're going to label that x prime. Remember, this is your image. We need to label it prime. Y, okay, y started at -3, +4. Make sure I wrote that one down correctly this time. We're going to leave x the exact same at -3. We're going to change the coordinate of the y to a -4. So we go -3, -4, and there is y prime, okay? And it look at the line of reflection, it's equidistant, okay? Next we have z. Z was at -1, +1. We're going to, again, we're going to keep x the same at -1. Now we're going to change the sign of y from +1 to -1. And there's going to be z prime. And when we connect them, we're going to see how, if I could draw a straight line, we're going to see how they are, some points went up and some went down. When your line of reflection goes through your pre-image, your pre-image and your image will overlap, and that is what's supposed to happen there. Okay, let's take a look at B. I have already gone through and put the pre-image on. It's the exact same thing. Go ahead and pause and do that for me, please. This one we are going to be reflecting over the y-axis. Okay, so here's the y-axis. Remember, our y-axis rule is going to go from xy. We are going to change the opposite coordinate, leaving the y coordinate the exact same. So let's take a look. Again, you can count to the line of reflection and count to the other side if you would like. Here we're going to look at x, that -5, -2. I'm making sure I'm writing that down correctly this time. I'm going to go ahead and write out y and z with the same color. Here are our pre-image points. We're going to go and take x. We're going to just change the x coordinate so that -5 is going to turn to a +5. Y will remain the same. So we're going to wind up with 5, -2. Here is your x prime. Next, your -3, 4 for y. You're going to change the sign of the x coordinate to a +3. Leave y the same. So we have +3, +4 for y prime. And then -1, 1 for z prime, we're going to leave the x, sorry, we're going to change the x to a positive, leave the y as a positive. And I've got my z written right there. We're going to connect those so we can take a look. You can use a straight edge. I'm going fast to kind of make the video shorter, but use a straight edge so you can see it a little bit more clearly. We have the same shape, same size, it's just been reflected. Okay, so let's talk about letter C here. We've already have the pre-image there for us, so yay. We're going to talk about reflecting over the y equals a number. So here we go, y equals -1. This is where there is no rule to follow. You need to count how many to the line of reflection and then count further. So we're at y equals -1. So at y equals -1, on your y-axis, find -1 right here. And we want to cross through that point going horizontal. Okay, y equals a number is a horizontal line. So now we're going to take each one of these points and we're going to count to the line of reflection, count that many to the other side, find our coordinates. A, we're going to count 1, 2, 3, 4 to the line of reflection, count 4 more to the other, 1, 2, 3, 4. Here is going to be A prime. Again, make sure that you are counting from the origin. Where are our coordinates on the x? -5, y, +5. Sorry, -5, -5. -5 in both directions. Let's take a look at B. We only move 1 to get to the line of reflection, so we move 1 past it. Very easy movement there. So here B is at +2 on the x, -2 on the y. C, I encourage you to pause and try it on your own, please. You already saw what we did with A and B. Please pause it, try it on your own. C, we're going to move 1, 2, 3 to the line of reflection, 1, 2, 3 past the line of reflection. And make sure you label prime on all of these. And then we connect them. I'm just going to connect them with a straight edge real quick, just to make it, these are a bit longer lines. I'm pretty quick at using this straight edge. And we're going to see same shape, same size. C prime is at +1, -4. All right, next, we're going to take a look at looking at these coordinates. They're already plotted for us again. We're going to graph the image reflected over y equals x. Remember that y equals x is a 1-to-1 ratio slope. It's going to go positive. So here we go. If you want to use a highlighter, if you want to use a pen, whichever one, here is your line of reflection. This one, we want to make sure that we're following our rule, not counting. Okay, so our rule here, all we had to do with y equals x was take x, y, and we're just switching the two coordinates around. That is it. Flip the two coordinates. So, again, please do not count. Hey, look, guys, the line of reflection is going through the pre-image. Remember what happened up here? So our image and our pre-image are going to overlap each other. So let's take a look at B and B prime. B was at -3, +3. Switch them around. So the +3 now becomes the x, the -3 now becomes the y. So +3, -3. Here we're going to have our B prime. C was at 1, 4. Switch them. 4, 1. All we're doing. So we go to +4, +1. There's your C prime. D was -2, -4. The rule tells us just switch them. -4, then -2. So -4, -2. And we're going to see here D prime, as we just discussed, because the line of reflection went through our pre-image, the pre-image and the image will overlap each other. And there they are overlapping. All right, we got a few more problems to go over. We're going to take a look here at, we're given that T is at this location, and we want to know what line of reflection gets the image to these new coordinates. So let's take a look here and let's go ahead and plot T. T is at -7, +4. Okay? So here's T. We're going to take a look at T prime, and it's going to be at +7, +4. So here's T prime. So there are a couple different ways that you can look at this. Let's take a look at first what happened. Let's write this quickly. We got t is at -7, 4. So these are your x, y coordinates, okay? Your x and your y. When we go to t prime, we're going to notice that we're at +7, +4. So we need to look at what happened between these coordinates. With reflection, this is how you do this. Okay, you look at what happened. Well, I'm noticing the numbers stayed in the same place. So we still have the x and the y, but I'm also noticing x turned to the opposite sign. So that means it was in the rule, it's a negative x. So when you have xy goes to negative xy, this is where the y, so we didn't switch them, okay? We did not switch them, so that's not going to y equals x or y equals negative x. It's going to be a reflection across a certain axis. And that's going to be the axis of the coordinate that did not change. Y did not change, so this is a reflection over y-axis. Y stayed the same, x changed, so this is a reflection. Another thing you can do is you can take these and go, okay, they're horizontal, you can count 1, 1, 1, 1 until they meet in the middle. That is another way of doing that if they're horizontal or vertical. All right, last two. We'll talk about what coordinate notation we have here. Describe what transformation happened. All right, let's take a look at this one here. Let's look at all of our coordinates and see what's the difference between them. Well, the first one here, I'm noticing there's just a change on the x coordinate. They didn't switch places. Q and Q prime. Okay, y stayed the same. I'm noticing that the x is the only thing that changed. So again, what's happening here is x changed. That's where that negative's there. Y stayed the same. And if we go back and we look at our rules, or we look at the previous problem, that's going to be your y-axis. So this is a reflection over the y-axis. X are opposite. We're going to write the reasoning just for our notes. Y stayed the same. Sorry for the sloppy handwriting. I'm just trying to get it done quickly. So this is your y-axis. Now we take a look at the next one. What I'm noticing is the x-coordinate did not stay the same at all. It's a completely different number. But look at just right here at just j and j prime. If you notice, they switched places. The 2 went from x to y. The -1 went from y to x. Look at k and k prime. Oh, same thing. They simply just switched places. L and L prime, same thing. Your x and your y switched. Lastly, M and M prime, same exact thing. So we go back and we look at, hey, what rule was this, when they just switched places? Also, if we plot them. Go ahead and pause the video and plot both of these because I want you guys to visually see it as well. Go ahead and pause. Mine are about to pop up here in a second. Please pause the video and plot both the pre-image and the image and connect the points. But what you're going to notice is this reflection, it's not horizontal or vertical. When they switch, we're going to notice that your line of reflection is going to end up being, because these switch places, your y went to the x position, your x went to the y position, x and y switched places, put places, that way we don't think signs, places. And when x and y simply just switch places, this is reflection over y, make sure it's on the screen, y equals x. So that's going to be that diagonal positive slope, and it's really badly drawn, but there you go. Please, you can search my YouTube for other reflection videos from my previous years of teaching. You can YouTube any other reflection videos on a coordinate grid, or ask your teacher if you have any questions.